Today, we're exploring what happens when art meets code and why simplicity might be the highest form of engineering. This is Confluent Developer.
What really mattered was data and not the actual implementation. Reducing complexity and abstracting away is, I think, the key when starting something early. I made so many mistakes. I remember this being like, I will need to automate my way out of this one day.
Hello, everyone. I'm Polak, and welcome to Confluent Developer, where we uncover the human side of software. My guest today is Daniel Doubrovkine, or DB, a lifelong builder whose story spans continents and generations, from refugee roots in Moscow to the hacker underground of 1919's Geneva, to leading the creation of artsy Art Genome project that exists till today. We talk about building search engines before vector database existed, keeping developers happy, and why sometimes the best architecture is the one you delete. Let's get to it. Hey, Daniel.
Hi, Adi, how are you?
I'm good. Or whether I say DB.
Oh, that's right. You could call me DB.
That's awesome. You know, what's the story behind DB?
Oh, the B is after Alexander Blok, the Russian writer. I joined this BBS in the early 90s called Boris and Co. in Geneva, Switzerland. I needed a username, so I couldn't come up with one. I thought about like what kind of pseudonym can I use in this software pirating BBS, and I used Block, which is a pseudonym that my father used for quite some time. But I spelled it Block. And it needed to be 6 letters, so it became D Block, which stuck with me through high school, college, and so on and so forth. So now I just go by DB for the last 30 some years, and even my kids call me DB sometimes.
Wow, that's quite a story. Super interesting. Thanks for sharing. I'm curious how the kids reacts to that. So it's definitely
They
means
mostly
it
roll
sticks.
their eyes.
Yeah. Cool. So welcome to Confluent Developer Podcast. I'm super excited to have you on board. I know you have many years of experience, but the fact that I know you doesn't mean that our audience, know you well. So maybe you can share a little bit about yourself, so they know you better.
Yeah, most definitely. I was born in Russia, in Moscow, and my family immigrated to Switzerland when I was 13 years old in 1990. We were refugees in Europe. I had no friends, so I picked up computers as my friends very early. I joined some hacker types, who also had no friends, and we made quite a group. Then eventually I started writing software, copying my very first one from SVM magazine. I remember copying like 2 pages of x86 assembly. I had no idea what that meant. And then it all worked out. So I ended up having a couple of companies, a long career in tech, mostly alternating between IC and managerial types. So I kind of go back and forth, and I think that's a common pattern in my history. I live in New York City in Manhattan. Have 2 teenagers that mostly roll their eyes on my nickname.
Yeah, or in anything. I mean, teenagers is is a pleasure, right?
We could talk about teenagers during this entire podcast if you want, but I am probably the wrong person to give any advice about teenagers. I'm doing my best. Still a mystery to me. None of them codes, and this is, I'm not sure if it's because I tried to convince them that it's a good idea or because I didn't try hard enough. I don't know. We can talk about it.
Yeah, it's interesting, but I guess that's a different mystery. Maybe one day we'll figure it out, but I'm not sure if parents will ever, even though we ourselves been teenagers a while back. So
True.
anyway.
In fact, they do remind me of my parents who used to yell at me, get away from the computer. This is useless. Nobody cares. Why are you wasting your time spending your entire day in front of the computer? My kids say that a lot. It's like, what do you even do?
Is that a real job?
Yeah, exactly. Like, you're doing nothing all day, just sitting in front of your computer.
Right. By the way, jobs. I was curious. What was your very first job? Do you remember it?
Yeah, I did some non-tech jobs very early. I delivered pharmacy medications on my bicycle in very, very early in high school. But because I quickly got into computers, I thought I'd get a job in computers and had an internship at this Swiss bank. Uh, I think I was 15, and my job consisted for 3 weeks to copy numbers from a paper ledger where somebody wrote them with a pen
Mm,
into a very early version of Excel. And I
wow.
made so many mistakes. I just remember this being like, I will need to automate my way out of this one day. There's no way this could be a job. But that was my first proper corporate job with, a paycheck, an equivalent of, your W-2 and something like that. And then I quickly pivoted into working in this computer store, mostly uh, assembling PCs, being paid cash under the table because I was, kind of underage, but I knew about computers, so there weren't that many people in the early 90s that did. So
Yeah.
I really enjoyed that job, is working with people and selling and assembling PCs in one of Geneva's um, computer stores.
Yeah, I mean, you gave them value, and so it's back in the days. It's hard, like you mentioned, it's hard to find people that expertise. And even today, I'm not sure if the new generation knows how to assemble things, or they just go to a shop and buy stuff.
I probably don't know how to assemble a modern PC anymore. It's been a while. It's really fun. I made so many friends in that little nerdy crew of oh, you've got the new 486. It's got so much RAM.
Yes,
My
compared to
first hard
today.
drive, 40 megabytes. My
Oh wow,
second, 250. I think I spent like $2,000 buying that. It's
wow, wow.
crazy.
T- Today's like, can you run AI on it? No. Okay, what is it worth?
You can run this very slow AI on it. Very early
Extremely,
LLM, baby.
yeah, extremely slow. Not a lot of tokens to process and so on. Yeah,
Things were
it's
simple then. Things were very simple.
yeah, that's true. Things were very simple.
Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now, back to the show.
Let's jump into the future for a little bit. What was some of the software challenges you faced, and if you can walk me through like how you solved it and what some best practices and learnings that you can share?
Yeah, I think a good job to talk about that had a lot of technical challenges that I dealt with very personally was my time at Artsy. It's ARTSY. I joined the company when it was in 2011. It was maybe a 7 people company, and then we will go and build the largest fine arts marketplace and most read online
Wow.
arts publication over 8 years, having raised $100 million and having many hundreds of people working at the company. But some of the initial challenge of that project was super interesting. It was called the Art Genome Project, where
Hmm.
art historians would classify works of art according to a quote unquote genome. So you'd have these features, let's say abstract expressionist work, and you'd have a value 0 to 100 of how abstract expressionist it is, or let's say pop art, and artists and artworks would be classified that way. So Andy Warhol would get 100 in pop art,
Hmm.
and so on and so forth. So there were about 1,200 of these genes, and what we were trying to do is a similarity engine. And I didn't know much about KNN vector search at the time, and some people that preceded me built a very heavy prototype on JBoss. They wrote this like crazy thing in Java, very over-engineered, very enterprise software-like, that took 20 minutes to boot, load all the data, try to build this nearest neighbor graph, and then you'll be able to search through the graph. But almost nothing worked. So when I took over the project, we restarted from scratch. I went around New York startups asking, how do people build startups today? Everybody told me, you should be using Ruby on Rails, MongoDB, and that's how we rebuilt the initial version of search. It was a very brute force KNN vector search in its version 1. And then eventually it became more sophisticated. We used something called locality sensitive hashing, and then finally an algorithm called an descent. Spent probably 2 or 3 years building various iterations of the search engine. And I wrote quite a bit of it at the time myself. But I guess the conclusion of all of this was that in the end, what really mattered was data and not the actual implementation. The data made the engine really successful. High quality data entered by humans. And then finally, all of this was replaced by off-the-shelf nearest neighbor search implementations. We used Elasticsearch, more like this package. And then now you have gajillion nearest neighbor vector search engines that can do much, much higher dimensions and return results almost instantly. So all this exciting new technology that we had to develop from scratch is completely commoditized today and is available almost instantly. So that was a fun technical challenge because we had to produce results that were not only fast but also good. And good was very subjective. We'd put art historians in front of the results and say, hey, what do you think of this search result? Here's an artwork. Here are similar works by other artists. Like, how do you feel about it? And they would feel so passionate and yell like, oh no, how do you dare put artworks between this artist and that artist on the same page? Like, that is absolutely unacceptable. So, or they'd say like, wow, how did you find this amazing connection between these two artworks? Like, this is magical. It's like a museum curated show. So that was fun.
Yeah, it sounds like a very hard things to do. I was curious. You mentioned there was different things that you had to re-implement. But first, the fact that someone or other companies already implemented and made it a commodity KNN and other algorithms, it's fascinating by itself, I think, because if you look at the world of open source, there's so many things already implemented, and for us, we can lead with data and maybe tweak some things that already exist there. But I'm curious because you implemented a lot of core stuff. Is there anything that you remember kind of like profound, like maybe some of the hashing capabilities or anything like that you want to dive a little bit deeper, or perhaps, meeting some of the founders in the space and learning what are they doing differently?
I mean, I eventually hired people who were better than me. Like my computer science background is limited to college. Like I did graduate in computer science and then promptly forgot all the math that came with it. And so eventually we hired people who were PhDs in math and things like that to do all this work. And most of the time it involved reading papers and trying to implement the papers as opposed to necessarily like invent our own. So it's not like we invented some new way of doing nearest neighbor search. What we did have to struggle with is performance of these things, because it's one thing to take a paper and re-implement an algorithm. It's a completely different performance pattern when you actually execute it. So when you're working on real-time systems, you have to return, search results within some milliseconds later, and that was definitely challenging in the early days of these vector search implementations. And I didn't know the future of LLMs which use this kind of technology. Like none of that was we could have never guessed it would be all that. So it became commodity later. But while we were working on it, there was nothing off the shelf, or very little off the shelf that worked for us, and we felt like we needed to build our own for it to be like our core technology. In the end, it was only our core technology for a very brief moment, and then the world kind of flew by with off-the-shelf software that did it. So can't claim any scientific breakthroughs in this work. And I think it's appropriate for a startup where ultimately the goal is that is a delightful user experience as opposed to something deep and complicated. And so we focused on that. I built the first version of the bidding engine for auctions, and I tried to apply the same approach of like the nearest neighbor search was way too complicated when we started. We thought it would be like such a hard problem, and so we looked for a very hard solution. And when it came to building a live bidding engine, I heard the same things from all kinds of people. I went to Wall Street, and everyone was like, "Oh, an auction, a live auction. That's what we have on the stock market. That's very,
Right.
very hard. You need low latency. You need a lot of memory. You need to solve for a lot of concurrency." And then I went to art companies and like, yeah, we use paper, and you write your bids on the
Very
at the bottom of
sophisticated
the
paper.
page. Like, what's in between? So I opted for almost the paper version, so something extraordinarily simple, just built on top of our existing implementation for e-commerce, and practically this was just a single-threaded background job that would run the auction while people could place bids. So I separated the user experience from the actual part that needed to be really fast, and this was a good idea. In the end, people would not notice that something was happening very slowly. We faked it in the user experience, like in the UI, basically, and the auction would catch up as especially the last like 5 seconds of an auction. People are trying to snipe. It's when they try to place a bid as late as possible to get their winning bid, to be the max bid. And so in the background, we just like ran the auction, and there's an animation, and 15 seconds later it tells you, oh, you won. So you don't need to know it took 15 seconds to calculate. Like,
Right.
it looks instant. You're just waiting for this moment. So a lot of the user experience of something that needed to be super fast could be faked to look fast. It just didn't need to actually be fast. Eventually, we built a system that was fast, but it
Yeah.
was maybe version 5 of the system.
Yeah. So if I understand correctly, you had to build to it, right? Because you knew you needed real time, but real time is it takes time to build. And so building up to it with other versions until you get to a real time experience, that was the path, right?
Yeah, and it's really about keeping things simple. And we say, oh, the KISS principle, keep it simple, stupid, but very often we don't actually do it. So our final version for the bidding engine is ACA-based, actor-based system with like real-time events, and it's incredibly complicated to understand what's going on in the system like that. And of course, it scales incredibly well. But
Right.
the first 7 versions of the system were written in Ruby in like 100 lines of code, and that carried us through many hundreds of auctions before we hit the actual scale problems of our implementation. So it's premature optimization and keeping things simple. It's pretty amazing to experience that in real life. I know about these challenges. I mean, I faced them a little bit before, but starting a system from scratch and then seeing it actually happen was very educational. And that's why you go work in startups, is to start something greenfield sometimes.
Yeah, that's exciting. As a greenfield and also with a very small team. You mentioned that you started with 7 people and then the company grew to a
The
couple of
whole
hundreds.
company was 7 people. I think I was the 7th person there.
Oh, wow. Wow. And then you raised $100 million, right?
Yeah, something like that.
Back in the times where that was like a fortune. It's like it's like raising multi-billion dollars today. Equivalent.
Yeah, we didn't raise it in one round though. We did series A, B, C, D. So it took its time. The company is very much around today. Artsy.net. It's an amazing marketplace for fine art. I still buy art on Artsy. I collect some prints like Joseph Albers and artists from the 60s from the past century, and I buy it all on Artsy. You have access to like all the galleries, all the auction houses. It's pretty great.
Very cool. So I'm curious, if you had to kind of like rebuild a solution today, giving, all the different solutions that are available on the market, like out of the box Canon and the data streaming solution and so on, like what would you do differently?
Well, I think a lot of the software today is available because the time has come. These systems are scaled and work very, very well. So now probably half a person in like half a day could assemble artsy version 1 like very, 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 very easily. And there is endless options for the software. For vector search and things like that. I think I'd still start with my all-time favorite, like Ruby on Rails, and then pick the actual search engine, like I don't know, Elasticsearch, maybe not, OpenSearch. I worked on that fork for a number of years. Maybe like a simpler, newer vector search engine. I still love MongoDB. Still use it for my pet projects. I think these are good, simple startup systems, and they're very low maintenance. Like I don't know why people hate MongoDB so much, but it's just like garbage in, garbage out, set it and forget it. It works great and scales to like 95% of projects that will die anyway because your company may not have that future. So that's still my preferred stack for getting something bootstrapped like very, very quickly. Rails, whatever database, Postgres or MongoDB, and then maybe something specialized for the specific problem of vector search.
Right. Would you consider like a cloud service, like something that was already managed and built out, or would you rather like have the solution managed in-house?
Well, it has to run somewhere. And of course, you'll be running things cloud-based. So for my pet projects, I use DigitalOcean a lot because the app platform is super simple and you don't have to maintain the hardware. So that's a viable option to get started. Absolutely. I'm not in the camp of premature optimization, like throwing things onto your own hardware. Then you have to have people who maintain all this stuff. So reducing complexity and abstracting away is, I think, the key when starting something early. You want to give yourself options, but I like the idea that things can run locally very, very easily. And I like the idea that my infrastructure, cloud-based infrastructure, is painless, and that's worth money. I just don't want to deal with it. So I want something extraordinarily simple, and there's so many of these things out there that all work quite well.
Simple and painless.
Yes, and cheap. I think it has to be cheap, and it's important to know when these things start hitting limits of cheap. Like Heroku used to be really, really cheap to get started. Artsy started on Heroku, and then when you start scaling out, like it becomes significantly more expensive. You pay overhead there. So like today, I would hesitate starting on that platform because I know that the limit is not that far off in terms of like cost benefit. There's others. So it's good to know where these limits are and then avoid future migrations. But a simple architecture always wins. And then something portable between services where I can say, oh, like DigitalOcean doesn't work for me. I'll redeploy on something else, Versal or whatever other platform out there. I don't think it's that important. But one thing that I always optimize for is developer happiness. And you should take the team you have. Like if DB is the team, Ruby on Rails and Ruby, it makes me happy.
Okay.
If you are the team, maybe it's Node.js, TypeScript, and something else. Others will want Python and Flask. Who knows? I think that you should work with the people you have and be like, what would you choose? What is your preferred framework? Like some want to optimize for something super new and super exciting that everyone's talking about like today, like the cutting edge, and that's a great choice. And others like, oh, I'm very conservative. I want the thing that I know will work for sure. So that also works. In fact, all of it works.
Yeah, it's very interesting. Engineering happiness. It's kind of it could be a metric for engineering, or it could not, because it's not always, it's hard to explain it. I think sometimes.
But measuring developer happiness. So like, are you happy now? Like, how happy are you?
Yeah.
So
exactly.
You used Ruby on Rails. Are you happy now?
Yes. Well, if you're being paged every night for a couple of times a night, probably not happy. But
You-
technology choices.
so many people love Go so much, and I think its error handling is insane. And so I make fun of sometimes of Go programmers. I'm like, so it's more lines of code to do the exact same thing. Are you happy now? That's my
Right.
approach to
That's
this.
true. All right. Divi, thank you so much for sharing your experience. It was a pleasure. If there's one thing I'm taking away out of that is, make things simple and easy to use and focus on the experience for the customer, because that's what really brings the value at the end of the day. So thank you.
Yeah, don't forget to make developers happy as well with what they're working on. And thank you for having me.
Yes, absolutely. We always want to make developers happy. Of course. Guess till next time.